couple of the more common questions that come up on this homework assignment. One gets back into logarithms, so probably a good time to review this. Logarithms, again, they're exponents. So when exponents are being added, the larger numbers are being multiplied. So we can combine these. Log of secant x times sine x. Put them all in one logarithm. Okay. And it's in an absolute value. You really don't have to worry too much about why that is. Just accept that it is for now and kind of run with it. It doesn't really change the problem much. So secant is 1 over cosine. Sine of x stays the same. So this becomes sine over cosine. So that becomes tangent x. And again, keep it in absolute values. Changes the overall, whether it's positive or negative a little bit, but that's the main thing that you're supposed to take from this problem is just how to combine logarithms again and put some trig values in there. 103, the book makes it sound a lot fancier, but they're basically saying, why is this not true? They have sine of theta equals square root of 1 minus cosine squared theta. Well, it kind of seems like it should be as you start to simplify it, because 1 minus cosine squared, we've done this a few different ways. It comes from the Pythagorean identity, but it's square root of sine squared at that point. And you may be thinking, all right, well, maybe it's plus or minus because we're taking the square root. The way that works is that if they give you a square root in the beginning, you have to go with what we call the principal root, because this is positive and it was given to me. I got to leave this thing positive all the way through. All right. Now, if this side was squared and I was taking the square root, if this wasn't here already, that's when it's plus or minus. I mean, that sometimes trips people up. But this would be the proper way to go. This is still positive. And it seems like, since that's supposed to be positive and you're taking the square root, that maybe they should be equal. So we can always check a graph first. Now I'm going to explain kind of through logic more so than just an algebra process. The book, I think, says there's many answers for this, so I'll give you some different ways to think about it. If you look at the graph, and I put it in Desmos, here is sine x, which we're familiar with at this point, or should be. And here's 1 minus cosine squared x. It almost looks like a bouncy ball, which I couldn't help but create one, so there's a little bouncy ball going back and forth. But you're only getting the positive part of sine there. You're not getting the negative parts of the sine wave. So the key in really what's going on, it's right here. And I'm going to make a little chart. I think this will illustrate it. If I pick an angle, and I want to see what the square root of sine squared is. Let's just pick some of our more familiar points. All right, these should be enough to get us the idea. So be careful how you work this out. Sine squared theta, that's the same thing as saying sine of theta, get a value, and then square it. Okay, hopefully that's kind of getting you a hint as to what's getting ready to happen. So if I put in 0, all right, well, sine of 0 is 0, and then I square it, it's still 0. All right, sine of pi over 2, that's 1. I square 1, it's still 1. This is getting pretty boring so far. Sine of pi is 0. Here's where it gets interesting. Really anything you plug in past pi, but less than pi over 2. So put in 3 pi over 2. All right, sine of 3 pi over 2, that's down at -1. Now if you square -1, you get 1. And what's going to happen, any value between pi and 2 pi, if you take the sine value of it, you get a negative answer, because y part is less than 0. It's down here. Then you square that negative and you get a positive. So that's really the key to what's happening when we square these values between pi and 2 pi. They become positive, and it just kind of reflects, back to the graph, just kind of reflects all the negative pieces of the sine wave back up to the positive part. And that's why you get your little bouncy ball.